Hello my dear students and welcome back to the chemistry classes. So student, today we shall discuss about the catalysis part in surface chemistry chapter CET part. Okay. Now what is catalysis? Okay. Catalysis is a process of increasing the rate of a reaction by using a substance called as a catalyst. Okay. I'll write in short, increasing rate of a reaction by using catalyst. Catalysis is a process of increasing the rate of a reaction by using a substance called as catalyst. Then what is a catalyst? Catalyst is a substance which will increase the rate of a reaction, okay, by decreasing the activation energy of the reaction, but the catalyst will not undergo any permanent change. Okay, so catalyst ಅಂತಂದ್ರೆ ಏನು, catalyst ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅದ್ದು ಏನು ಮಾಡ್ತದೆ, ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತದೆ. ಓಕೆ, ಬಟ್ catalyst at the end of the reaction ಅದು ಇನಿಷಿಯಲಿ ಹೆಂಗಿತ್ತು ಅದೇ ರೀತಿ ಉಳ್ಕೊಂತದ. ಅಂದರೆ catalyst ಮೇಲೆ ಯಾವುದೇ ರೀತಿಯ ರಿಯಾಕ್ಷನ್ ಅದ್ದು catalyst ಮೇಲೆ ಯಾವುದೇ ರೀತಿಯ ಪರಿಣಾಮ ಇರುವುದಿಲ್ಲ. Okay, so reaction does not change anything regarding the catalyst. Only catalyst will change the activation energy of the reaction, and it may increase the rate of a reaction or decrease the rate of reaction. Okay, this is regarding about catalysis and catalyst. Now the characteristics of catalysts are very important. Okay, based on this many questions have come, and let us see those characteristics one by one. First thing, that it never initiates a reaction. So catalyst will never initiates a reaction. Okay, means see, if two reactants are there, X and Y, and say O is our catalyst and the product formed is XY. So here catalyst will never initiate these two reactants to react. Okay, these two have to start reacting, and slowly then catalyst O will increase the rate of reaction. Okay, so a catalyst will never initiate a reaction. It just increases the rate of reaction, but it will never initiate a rate of reaction. Second, it does not get affected by reactant and product. So as we have already said that at the end of the reaction, the catalyst will be reproduced as it was in the initial state. Okay, so reactants and products do not affect anything regarding the catalyst. Second. Third one, it does not shift the equilibrium position. In fact, it catalyzes the forward and backward reactions. Say, if this reaction is a reversible reaction, suppose this is one reversible reaction. Okay, we know that in case of reversible reaction, at some point of time equilibrium state will be reached. What is equilibrium state? At that particular state, or at that when the concentration of equilibrium state is a position wherein the concentration of reactant or product will not change, it will remain the same. Or in other words, if I have to tell you what will happen at the state of equilibrium, the amount of reactant getting converted into product will be equal to the amount of product getting converted into reactant. So that position is called as equilibrium position. Okay, so catalyst will not change the equilibrium position. The equilibrium position will remain the same, but what it will make, what the catalyst will do is it will make sure that the equilibrium position is reached quickly. That's it. Okay, equilibrium position will remain the same, but it will make sure these reactant and product will reach the equilibrium state very quickly, and this catalyst will affect the reactants to give product, and also this catalyst affects the products to give back the reactant in the same way. So catalyst will not alter on a forward reaction or backward reaction. In fact, it is going to catalyze both forward and backward reactions equally. Okay, next, fourth one, it does not alter the path of a reaction. It alters the activation energy. That is, activation energy either decreased or increased. Okay, this means what? See, we already have said that catalyst will increase the rate of reaction or decrease the rate of reaction. Now this factor we have studied in chemical kinetics chapter, where we have said that the catalyst, when it decreases the activation energy, let us say, okay, let me plot a graph here. okay, and let us say this is our normal reaction without catalyst, okay. Okay, and let us say this is using a negative catalyst, and let us say another color, this is using positive catalyst, okay. And we all know this point, these 3 points are called as activation energy, okay. So in case of normal, this is, let us say this is normal reaction with no catalyst. Now this black color path is reacting with catalyst, so I'll say EAC or positive catalyst, let us say positive C with positive catalyst, and this above one, let us say this is activation energy in case of negative catalyst. So if you see now that in case of positive catalyst, what it is doing, it is decreasing the rate of reaction. We have plotted this graph, energy versus reaction coordinates, or simply reaction path we can say, okay, reaction path. So if we can see, when we use a positive catalyst, what is happening, see the path is remaining the same, there is no change in the path. Means in this when you use catalyst or when you don't use catalyst, what is going to happen is the reactant are going to react with one another, they are going to attain this threshold energy, okay, or a transition state. Let us say they are going to attain transition state, and from the transition state they are going to give you product. Okay, what is happening if you use a catalyst, energy of activation is decreased, means the transition state will be reached early, and those transition states are decomposed further to give you product when you use a positive catalyst. When you use negative catalyst, what's going to happen? The activation energy is increased, means the transition state is going to attain slowly, very slowly, and once they attain transition state, later the decomposition takes place. Okay, so the positive catalyst, what it is doing, it is decreasing the rate of activation energy. You can see here the red color one, which is without any catalyst, is having higher activation energy compared to positive catalyst. And when you compare the reaction without catalyst and that of negative catalyst, in case of negative catalyst, the energy of activation has increased. So when the energy of activation has increased, rate of reaction will be decreased. Or when you use positive catalyst, energy of activation is decreased and rate of reaction is increased. Simple common sense. When activation energy is decreased, why? The products are obtained easily. Means see, when the activation energy is, means when the threshold energy and average kinetic energy, when the difference is large, you have to provide more amount of energy. So more amount of energy you have to provide. When I am saying we have to provide more energy, means we have to provide more activation energy, then the threshold energy will be reached, then the product has to be produced, isn't it? When the gap is large, amount of energy has to be supplied will be large, so it will take more time. When it is taking more time to attain that threshold energy, the rate of reaction is slow. Okay, when that threshold energy only is reduced, means when the gap between average kinetic energy and threshold energy is reduced, means what? We have to supply less energy. When we have to supply less energy, it is going to take lesser time. When it is taking less time, so the reaction is happening very quick. Understanding it? So this is regarding the catalyst. Means when we use a positive catalyst, energy of activation is decreased, products formed quickly. When you use a negative catalyst, energy of activation is increased, so product formation will be delayed. Okay, then fifth one, it does not alter the thermodynamic properties, that is free energy, that is it is not going to change, Gibbs free energy, okay, enthalpy of a reaction and entropy of a reaction. It just what? See, catalyst is just doing what? It is just decreasing the activation energy. That's it. The gap between average kinetic energy and that of threshold energy, it is just decreasing. Okay, so other properties like Gibbs free energy, enthalpy of a reaction and entropy of a reaction, they will remain the same. It is not going to change. Now this has been asked many a times for 1 marks. Okay, in that is twisted way, catalyst will alter these or catalyst will not alter these. In that format they have asked this question. Next, the last one is they are highly active. Okay, we'll see what is meant by they are highly active and highly specific in their action. Highly specific in their action. Now first let us see what is meant by highly active. See, this we have studied regarding enzyme catalysis. Best example or in day-to-day life what we see is that, see, when we want to convert the milk into curd, how much amount of catalyst we are using? Only 1 drop or 2 drops of catalyst we are using. Heppachudu. Okay, I mean the enzyme that we are using is very less compared to the total volume of the milk, but that small amount of enzymes are converting that big volume of milk into curd. Therefore they are highly active. They are highly active. They can convert large amount or large volume of the reactants into products by taking very less amount of the catalyst. Okay, that is the meaning of highly active. Second part, highly specific in nature. This also you should know that not every catalyst, any catalyst will catalyze all the reaction. No. Okay, for a particular reaction there will be a particular catalyst. Okay, we cannot say that all the reactions all the reaction can be catalyzed by using any of the catalyst. No, ಪ್ರತಿಯೊಂದು ರಿಯಾಕ್ಷನ್ಗೆ ಅದರದೇ ಆದಂತಹ ಕೆಟಲಿಸ್ಟ್ ಇರ್ತದೆ, ಅಥವಾ ಪ್ರತಿಯೊಂದು ಕೆಟಲಿಸ್ಟಿಗೆ ಅದರದೇ ಆಕ್ಷನ್ ಇರ್ತದೆ. ಆ ಆಕ್ಷನ್ ಪ್ರಕಾರನ ನಾವು ರಿಯಾಕ್ಷನ್ನ ಚೂಸ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಓಕೆ, ಸೊ ಈಗ ಹೈಲಿ ಸ್ಪೆಸಿಫಿಕ್ ಇನ್ ನೇಚರ್ಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ, ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್. ಸಿ ಹಿಯರ್ ಇನ್ ಬೋತ್ ದ ರಿಯಾಕ್ಷನ್ಸ್ ಯು ಕ್ಯಾನ್ ಸಿ reactants are same, that is carbon monoxide and hydrogen. Illu carbon monoxide and hydrogen, but look at the catalyst. Here I am using nickel as a catalyst, and look at the product that I have obtained. It is methane gas and water. Okay, whereas when I use copper, then I am getting formaldehyde. So these two reactions show that a catalyst is very specific in its action. Okay, it is very specific in action. Even in case of enzymes, we have seen that only this what in sucrose can be converted into glucose and fructose by using invertase. Even milk is converted into curd by only one type of enzyme. What is that? Lactobacilli. Only that lactobacilli can produce, that is the enzyme that will convert our milk into curd. So they are highly specific in their action. Okay, so meaning of that is, they are highly active and highly specific in their action. This is the meaning of that. Moving on to the second part, that is types of catalyst. Okay, there are two types of catalyst. One is a positive catalyst and one is negative catalyst. So already we have discussed about the positive and negative catalyst, how a positive catalyst will increase the rate of reaction and how a negative catalyst will decrease the rate of reaction. Only the thing important is we have to remember some of the examples. Okay, we have to remember the examples. Okay, so for negative catalyst example is hydrogen peroxide will decompose into water and oxygen very quickly. Okay, so therefore what we'll be doing is we'll be adding a glycerol or acetic acid into that hydrogen peroxide, so that the decomposition of hydrogen peroxide into water and oxygen will be delayed. Very slow it will be. Okay, so example for negative catalyst is very important, that we have seen. Okay, next we have to see is what is meant by promoters and what is meant by poison or inhibitors. Okay, promoter, the word itself is saying promoting. Promoter means which will promote the reaction. So how? See, promoters increase the efficiency of a catalyst. Okay, what are promoters? Promoters are the substances which will increase the efficiency or which will increase the activity. Eradu same. Okay, efficiency ಅಂತಂದ್ರೂ ಒಂದೇ, ಆಮೇಲೆ activity ಅಂತಂದ್ರೂ ಒಂದೇ. So promoters are the substances which will increase the activity of a catalyst. What is example? Many a times has been asked. Molybdenum in Haber's process. E questions has been asked. Okay, so molybdenum in Haber's process increases iron's efficiency or iron's activity. Therefore molybdenum is, what is molybdenum? They are saying that molybdenum in Haber's process increases iron's activity. So therefore molybdenum is, that you have to fill. What is molybdenum then? Molybdenum is a promoter, not a catalyst. What is catalyst? Catalyst is our iron. Finely divided or finely powdered iron is our catalyst. Molybdenum is increasing the efficiency or activity of iron. Therefore molybdenum is a promoter. Okay, then poison or inhibitors opposite to that. Okay, so poison or inhibitors will decrease the efficiency of a catalyst. For example, again in Haber's process, hydrogen sulfide or carbon monoxide, they are going to act as poison or inhibitor, means these will reduce the activity of iron. Okay, instead, I mean, how that works process, let me tell you. See, it's very simple. Let us say I have got iron, powdered iron I have got here. Okay, this is in a closed chamber. This you will study in P block elements. Okay, and from one side nitrogen and one side hydrogen, they are pushing it. Okay, along with the nitrogen, you know, some traces of H2S and carbon monoxide will be there. Traces will be there. So usually you are expecting in the reaction what? Nitrogen will adsorb, nitrogen and hydrogen will adsorb like this on the surface of the iron, and this nitrogen will react with hydrogen and ammonia will be formed. Very quickly ammonia will be formed at a very high temperature and low temperature. Ammonia will be formed. Okay, after adsorption, ammonia will be formed. But sometimes what will happen, your H2S and carbon monoxide, they will get adsorbed on the surface of iron, so you will get less surface for the adsorption of nitrogen and hydrogen. So in this way they will decrease the efficiency of iron. Okay, so this is regarding what is meant by a catalyst, what are the characteristics of a catalyst and the types of catalyst, and what is meant by promoter and poison. Now we will move on to the next part, that is types of catalysis. Okay, so what is the type of catalysis? Let us see now. Alright students, now we will study types of catalysis. Okay, so basically there are three types of catalysis. So the first one is homogeneous catalysis. Okay, what is meant by homogeneous catalysis? Very simple, that the word homo refers to same, right? Homo refers to same. Geneous means same medium. So if the catalyst, so what is the meaning of this is both the catalyst and reactants are in same phase, or they are in the same state. If the reactants are in liquid state, our catalyst will also be in liquid state. If the reactants are in gaseous state, then the catalyst will also be in gaseous state. If the reactants are in solid state, then the catalyst will be in solid state. Okay, if both the catalyst and the reactants are in same state, physical state, or in the same physical phase, then the catalysis is called as homogeneous catalysis. Okay, now examples. These are some examples wherein ozone is reacting with nascent oxygen in presence of nitrogen monoxide, giving you this will decompose, ozone will decompose into oxygen in presence of nitrogen monoxide. Same thing goes as when sulfur dioxide react with oxygen in presence of nitrogen monoxide, giving you sulfur trioxide. So here both the reactant and the reactant are both in what? They are in same physical state, or they are in same physical phase. These are also gases. This is our catalyst is also in gaseous state. Okay, now most of the time asked question is that is homogeneous catalysis is occurring via adsorption or not. ಅಂದರೆ ಹೋಮೋಜಿನಿಯಸ್ ಕ್ಯಾಟಲೈಸಿಸ್ ಒಳಗಡೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗ್ತದೋ ಇಲ್ಲೋ ಅನ್ನೋ ಕ್ವಶನ್ಸ್ ಭಾಳ ಸರಿ ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, ಅದನ್ನು ವೆನ್ ವಿ ಸಾಲ್ವ್ ದ ಕ್ವಶನ್ಸ್ ದೆನ್ ವಿ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಪಾರ್ಟ್. ಓಕೆ, ಸಿ ಈ ಮೆಥಡ್ ಒಳಗಡೆ ಏನಾಗ್ತದೋ ಹೋಮೋಜಿನಿಯಸ್ ಕ್ಯಾಟಲೈಸಿಸ್ ಒಳಗಡೆ ಆಲ್ರೆಡಿ ನೀವು ಥಿಯರಿ ಒಳಗಡೆ ಕಲ್ತೀರಿ. ಏನಂತಂದರೆ ಸಿ ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೇವೆ ಅಂತಂದ್ರೆ ಈ ಹೋಮೋಜಿನಿಯಸ್ ಕ್ಯಾಟಲೈಸಿಸ್ ಒಳಗಡೆ ಅವರ್ ರಿಯಾಕ್ಟಂಟ್ ವಿಲ್ ಬಾಂಡ್ ಟೆಂಪರರಿಲಿ ವಿತ್ ದಿಸ್ ಎನಿ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್. ಓಕೆ, ಟೆಂಪ್ರರಲಿ ಏನು ಮಾಡ್ತದ ನಮ್ಮ ಕ್ಯಾಟಲಿಸ್ಟು ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಜೊತೆ ಏನು ಮಾಡ್ತದ ರಿಯಾಕ್ಟ್ ಆಗ್ತದೆ. ರಿಯಾಕ್ಟ್ ಆಗಿ ಜಲ್ದಿ ಟ್ರಾನ್ಸಿಷನ್ ಸ್ಟೇಟ್ ಫಾರ್ಮ್ ಮಾಡಿ ಜಲ್ದಿ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತದೆ. ಯಾಕೆ ಆ ರೀತಿ ಆಗ್ತದೆ ಅಂದ್ರೆ ಸಿ ದ ರಿಯಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಈಸ್ ವೆರಿ ಸ್ಲೋ. ಓಕೆ, ಬಟ್ ದ ರಿಯಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ ಓಝೋನ್ ಆ್ಯಂಡ್ ನೈಟ್ರೋಜನ್ ಮೊನಾಕ್ಸೈಡ್ ಈಸ್ ಫಾಸ್ಟರ್. ಅಂದರೆ ದಿಸ್ ಯು ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಸೀನ್. ಇಲ್ಲಿ ಏನಾಗ್ತಂದ್ರೆ O3 plus NO, they will react faster, giving you NO2 plus O2. Then again idan NO2 other that will react with nascent oxygen, giving you again NO plus O2. ಸೊ ಓವರ್ ಆಲ್ ರಿಯಾಕ್ಷನ್ ಆಯಿತು, NO2 NO2 ಇಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, NO ಇಲ್ಲಿ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. ಸೊ ಉಳಿತೇನು ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಓಝೋನ್ ಪ್ಲಸ್ O that will give you 2 moles of O2. ಸೊ ಇದರ ಅರ್ಥ ಏನು ಅಂತಂದರೆ ಅವರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ಫಾಸ್ಟರ್ ವಿತ್ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್. ಅಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗ್ತದೆ, ಅಡಿಸಾರ್ಪ್ಷನ್ ಆಗೋದಿಲ್ಲ. ಎಲ್ಲಿ ಹೋಮೋಜಿನಿಯಸ್ ಕ್ಯಾಟಲೈಸಿಸ್ ಒಳಗಡೆ ಅಡಿಸಾರ್ಪ್ಷನ್ ಆಗೋದಿಲ್ಲ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಅವರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ಟೆಂಪರರಿಲಿ ವಿತ್ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ faster and the product will be formed quickly. This is about homogeneous catalysis. Remember, this point is very very important, that a homogeneous catalyst do not adsorb. Homogeneous catalyst will do not adsorb, it is important, do not adsorb the reactant. Instead it develop some temporary bonds with the reactant. Remember this. Next, heterogeneous catalysis, totally opposite to that of homogeneous catalysis. Okay, hetero means different medium, the catalyst is present in different medium. Okay, so when both catalyst and reactants are in a different physical state or different physical phase, then the catalysis is called as heterogeneous catalysis. What are the example? Most of the time asked questions are these. Okay, first let us see vegetable oil, reduction of vegetable oil in presence of nickel, solid nickel, that we will powder it and we will use it, converting this vegetable oil into fat. Andre ನೀವು ಡಾಲ್ಡಾ ಅಂತ ಫಸ್ಟ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. Okay, dalda, that is nothing but fat oils that are converted into fat. Okay, so reduction of that oil in presence of nickel will giving you fat. Okay, then this is one example. So you can see here our vegetable oil is in oily, will be in which state? It will be in liquid state. Hydrogen is in gaseous state, but our catalyst is in solid state. So both the reactant and the catalyst are present in different physical state. So such an catalysis is called as heterogeneous catalysis. The next three reactions are very very important. Why? Because see, in examination they will ask you the industrial application part. Okay, industrial application part of catalysts. So there are three main industrial application of catalysts. This is applicable to both the theory, board examination point of view, as well as CET and NEET and JEE part of view also. Which is important is that the industrial applications of three main industrial applications of catalyst or heterogeneous catalysis. First one is Haber's process. In a Haber's process, we will manufacture ammonia. So in these reactants are nitrogen and hydrogen. Okay, nitrogen and hydrogen react in presence of a finely powdered iron. Okay, at a very low temperature and a very high pressure, giving us the ammonia. Okay, so this is the first industrial application of the heterogeneous catalysis, where you can see both the reactants are in gaseous state, whereas iron is in solid state, and the product ammonia is also in gaseous state. Next, second process is Ostwald process. In Ostwald process, we will manufacture nitric acid. What will manufacture? We will manufacture nitric acid process. HNO3 will be produced. Means this will be later converted into nitric acid. Okay, but the main function here is that ammonia and oxygen, they will react and they will give us nitrogen monoxide. Okay, so here both ammonia and oxygen are in gaseous state, but platinum is in solid state. So platinum catalyzes these two reactants, giving us nitrogen monoxide and water. Okay, so this is the second application in industries, that is in Ostwald process we will manufacture nitric acid. Okay, so the main ingredient is nitrogen monoxide, later it will be converted into nitric acid. Third industrial application is conversion or contact process. Third industrial application is contact process. So in contact process we will manufacture sulfuric acid. What we will manufacture? We will manufacture sulfuric acid. So here sulfur dioxide will react with oxygen in presence of platinum asbestos. Okay, it will react in presence of platinum asbestos. Asbestos sheet means, see, platinum is converted into sheet. Okay, it will be converted into sheet like. Now usually metal sheets ಹೆಂಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ತಗಡು, ಅದೇ ರೀತಿ ಪ್ಲಾಟಿನಮ್ ಅನ್ನ ನಾವೇನು ಮಾಡ್ತೀವಿ, it will be converted into asbestos sheet. Means ಅಲ್ಲಿ adsorption ಆಗಬೇಕಂತ, platinum should adsorb these two reactants. Okay, otherwise instead of platinum you can even use vanadium pentoxide. Okay, so here the main ingredient in to manufacture sulfuric acid is our sulfur trioxide. This sulfur trioxide later converted into sulfuric acid. So these are the three main industrial applications, and also these are heterogeneous catalysis, very important. Okay, very important. This heterogeneous process or heterogeneous catalysis, very important. One thing in homogeneous catalysis is what is important, that in homogeneous catalysis adsorption will not take place, whereas in heterogeneous catalysis adsorption of reactant takes place. In this process adsorption of reactant takes place on the surface of catalyst. Okay, so the questions they have asked is which of the catalysis works on the process of adsorption? What is your answer? It is heterogeneous catalysis. Remember this. Then third one is called as autocatalysis. What is meant by automatic? Automatic means manually we have, certain things we have to do manually, and certain things machine will do itself. Okay, so that is called as automatic. Now autocatalysis means what? See, one of the chemical it will catalyze the reaction. Means, see, what is meant by autocatalysis? Chemical reactions in which one of the product intermediate or one of the, instead of writing product intermediate, or I can say one of the reacting intermediate or product intermediate act as a catalyst. Okay, so one of the reactant or product itself will act as a catalyst. Which is the example for this is, see, hydrolysis of ester. What is this? Hydrolysis of ester. In hydrolysis of ester, what will happen? See, means ethyl acetate we have with us, and to this hydrolysis means addition of water. So we are adding water to the ethyl acetate. During this, what will be formed? Acetic acid will be formed. We know that acetic acid is an acid and it will decompose into CH3COO. H, it will decompose into CH3COO minus plus H plus, means here. So these H plus will later make this reactant or reaction faster. So autocatalysis means what? One of the reactant or product itself, it will catalyze the reaction, is called as autocatalysis. So this we have to remember. Okay, they will give you the example, and they will ask you what type of catalysis is this. So the answer should be autocatalysis. So this is regarding the types of catalysis. Now we will move on to the last part, that is enzyme catalysis and shape selective catalysis. Okay, now let us see that. Okay students, now we will study enzyme catalysis. Okay, so what are enzyme catalysis? Enzymes, let us see first. Enzymes are what? Enzymes, these are produced from living organisms, and enzymes are proteins of a high molecular mass, and they are highly specific and active in their action. Now these are some characteristic features of enzyme catalysis. Okay, we know that, and what is another famous name for enzyme is they are called as biochemical catalysts. So enzymes are also called as biochemical catalysts. Why enzymes are called as biochemical catalysts? Because see, the first thing is saying that these are produced from living organisms or by the living organisms. What are living organisms? Plants are there and animals are there. Now these enzymes produced by the living organisms is for some purpose. Like in humans, some of the enzymes are produced to digestion, for the digestion or for the absorption of a particular protein or vitamins. Okay, so these enzymes are particularly produced by as per the requirement is there are many enzymes are secreted in our body. Okay, for every enzyme has its own purpose. Okay, every enzyme has its own purpose. Okay, so therefore as per the purpose is there, enzymes are secreted, and as per that those enzymes are what? They are highly specific and highly active in their action. For example, many of the diabetic patients will be taking insulin. Why they are taking insulin? Because insulin is one of the enzyme produced by our body, so that whatever sugar is there in our blood, that has to be absorbed by our body, so that we will get energy for doing work and all. Okay, but in case of diabetic patients, what will happen? The insulin enzyme is not produced by their body. So what will happen? There is lot of sugar is there in their body, but the body is unable to absorb that sugar. So what will happen? So ultimately lot of sugar will be there in their blood. Okay, so if that sugar is not absorbed by them, then they will not be having enough energy to do the work and all. They become weak and weak and weak, even though there is lot of sugar present in their blood. So the doctor will suggest to take insulin. So they have to take from outside the insulin. Now sometimes there are so many diseases, like sometimes there will be blood will be clotted in one of the veins or the nerves near the heart. So when that blockage is there, our heart will be feeling that pressure, so light heart attack may occur. So what the doctors will do, they will give some tablets. So those tablets will particularly are the enzymes which will be this whatever blood has clotted, they will dissolve that clot. So what will happen? The blood flow will become smooth in that area. It will not do anything. The enzyme that the patient has consumed will not affect the other blood, but it will affect only wherever the blood has clotted, there only it will act. Okay, so these are some of the examples. I hope you are understanding. So the enzymes are produced by the living organisms. And what are basically enzymes are what? Basically the enzymes are proteins, and they are having very complex structure. Unlike the other catalysts so far what we have discussed are metals, okay, are metals or acids. Okay, they are having a very simple structure. But when I say that enzymes are proteins of high molecular mass, these are having a highly complex structure. Whereas the other catalysts are having simple structure, these are having very complex structure, and molecular mass is also very high. Okay, and as the enzymes are produced by living organisms, the other catalysts that we have so far we have studied, they are not they may be produced or they may not be. Most of them are not produced by the living organisms. Like metals are not produced by the living organisms, they are already existing in the nature. Okay, so that is these are some of the difference between enzyme catalysis and normal catalysis. Okay, now and unlike as I am saying that these enzymes are produced by the living organisms, they will work best as per our body temperature. Okay, in our body temperature only they will work best. If the temperature goes above 60-65 degrees Celsius, then the enzymes will get destroyed, so they will be action also be zero. Okay, so enzymes will work best as per our body temperature, whereas other catalysts, if you look into, they will require higher temperature like 100 degrees Celsius or 240 degrees Celsius, 500, 600, like that. Those catalysts will work at very high temperature, whereas enzymes will work best at our body temperatures. Okay, and these enzymes are also work best in a particular pH range, and the pH range is in between 5 to 7 the pH range is between 5 to 7. So remember students, they might ask this, that the normal catalyst will work at a very higher temperature and enzymes will work best at our body temperature or at room temperature, they will work best. Okay, and the pH optimum pH range for the enzymes is 5 to 7. Okay, then we will look into some of the examples. Now examples particularly you have to remember, because many a times they have asked questions on catalysis based on enzyme catalysis only, and they will ask you particular enzyme in a particular reaction. So I have given you some of the examples that you have to remember. What are those? See, basic thing is, when milk is converted into curd, what is the enzyme used? It is lactobacilli. Next, when sucrose is getting converted into glucose and fructose, what is the enzyme used? It is invertase. Okay, that's why we call it as inversion of sucrose. Inversion of sucrose we call it as, when sucrose undergoes inversion, glucose and fructose will be produced. So what is the responsible for that? The enzyme is invertase. Then comes urease. in this urease, urea will be converted into ammonia. Okay, then very important is zymase. Okay, so what the zymase will do, zymase will convert the glucose into ethanol. Very important, this is important. Okay, zymase is important. Then these two are important, lactobacilli and invertase, these two are important. Then comes pepsin and trypsin. Pepsin will convert the proteins into amino acids, and then trypsin will convert the proteins into peptides. Okay, now these are this is what is meant by enzyme catalysis. Okay, and what are the example for enzyme catalysis? Remember the example, students, that is very important factor. That is lactobacilli will convert the milk into curd, invertase will convert the sucrose into glucose and fructose, then yeah, zymase that will convert glucose into ethanol. These are the three important that at least you have to remember. Then mechanism, yes, so the mechanism of enzyme catalysis is explained by which method? It is called as lock and key mechanism. Why it is called as lock and key mechanism? Because the shape of the enzymes is complementary to that of the reactant. Complementary means, this we have seen in our theory, like if this is the shape of the enzyme which will be complementary to reactant. Suppose the reactant is having this shape, this is your enzyme and this is your reactant. So you can see that those two are having complementary structures. Means ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ ಒಂದಕ್ಕೊಂದು ಹೊಂದಾಣಿಕೆ ಆಗಬೇಕು, ಆ ಶೇಪ್ ಒಳಗೆ ಇರ್ತಾವ. and when these two will combine, there will be intermediate formed, then intermediate will be decomposing, again our enzyme will be reproduced. Therefore it's just like enzymes are going to act as a key. Okay, just like there will be a specific key to open a specific lock. Therefore there will be a particular enzyme that will convert the reactant into particular product. Like here, only trypsin can convert the proteins in our body to peptides. No other enzyme can do that. So it is just like a particular or a specific key is required for a specific lock. Same way a specific enzyme is required for a specific reaction. Okay, so that's why it is called as a lock and key mechanism. Then the next one, it is called as shape selective catalysis. Now it is also very important from theory as well as CET point of view. Okay, so shape selective catalysis means here the catalyst is having a particular type of shape, and these are very selective in their action. Okay, so shape selective catalysis means what? Zeolites. So what are zeolites? Zeolites are aluminosilicates. What are those? They are aluminosilicates, and these zeolites are having what? Zeolites are nothing but three-dimensional network structure of silicates in which few of the silicates are replaced by aluminium. Okay, so three-dimensional network means, I hope you can understand, like this structure you have to imagine three-dimensionally. Okay, next aluminosilicate, this is a general formula for the aluminosilicates. Okay, next, the shape of the pores or holes of these zeolites is how it is like honeycomb structure. We call them as honeycomb structures. What is honeycomb structure will look like? This is the honeycomb structure that is it is going to look like. And the pore size is in between 260 picometers to 740 picometers. Now the question comes, like, how do the zeolites work? Okay, here only I will take. How the zeolites will work means, see, consider a three-dimensional diagram. Okay, say this is a three-dimensional network in this honeycomb structures, right? like this, it will continue. Okay, so it's a three-dimensional structure. So what will happen whenever the reaction will takes place in these zeolites? What will happen? They will choose the zeolites in such a way that, okay, only the product required thing is will stay inside the zeolites. Okay, means suppose there is some reaction will takes place x plus y and it is going to give you xy, then the shape and size of this xy in such a way that it will remain inside these zeolites. Okay, and unnecessary things will go out of this, or what will happen, these products will come out of this and unnecessary things will remain in the network like structure. Okay, I hope you are understanding it. So the whatever reaction is taking place inside the zeolites is supposed to be in such a way that whatever the required product will be there, the shape of the product or the size of the product will be same as that of the pore size. Okay, so now pore size can be varied between 260 picometers to 740 picometers. So the product size has to be in between this. Why? Because the pore size we can make it in between this. Okay, so this is how the zeolites will be working for us. Then best example for zeolites is what? It is ZSM5, which converts ethanol directly into petrol. Okay, so this is about the shape selective catalysis of the zeolites and how the enzymes will work. What is the famous name for enzymes? It is also called as biochemical catalysts. And what are the characteristics of enzyme, that also we have discussed, and example for the enzyme catalysis, that also we have seen. So this is regarding all about, so in today's session we have discussed all about what is meant by catalysis and all. Okay, so in the next session we shall solve some questions asked on catalysis. Okay, in KCET what are the questions they have come, that we all will see in the next session. Okay, thank you so much, students.